Hello, everyone, and welcome. Today's lecturer is Sólveig Guðmundsdóttir Beck. Sólveig is a geoarchaeologist. She finished a BSc in geology from the University of Iceland in 2004 and an MSc in geoarchaeology from the University of Reading in 2005. She has worked on and off for the Institute of Archaeology since 2003, doing surveying, excavation, and stone analysis. And last year she finished her doctorate, and her lecture today is on her postdoc project. So when you're ready, Sólveig, welcome.
Thank you. Hello, everyone, and thank you for attending. My name is Sólveig Beck, and today I'm going to tell you a little bit about my part in the Sticks and Stones project, which is a 2-year work in progress. This is the first postdoctoral project that I take part in, and I'm looking at stone finds from 2 midden excavations at Tatsip Ataa Killeq and Igaliku in the Norse eastern settlement at the southwestern tip of Greenland. This project is mainly a collaborative effort between the University of Iceland, the National Museums of Denmark and Greenland, and the geological institutes in Denmark and Norway. The research is funded by RANIS, the Icelandic Center for Research, and the project is overseen by Dr. Orri Vestninsson, professor in archaeology at the University of Iceland, Dr. Jette Arneborg, senior researcher and museum curator at the National Museum of Denmark in Copenhagen, and Dr. Christian Koch Madsen, deputy director and researcher at the Greenland National Museum and Archives in Nuuk. Dr. Kasper Secher, a retired senior researcher at the Geological Survey of Denmark and Greenland, has been on hand, giving helpful advice on Greenlandic geology and source locations. And Maiken Djurhus Poulsen, a PhD student and researcher at the Geological Survey of Denmark and Greenland in Nuuk, has also been of great help with some of the analysis of the steatite finds. The Norse, they had their traditions and ways of life for which they needed tools and materials to maintain them. The aim of this project is to record and analyze in detail the raw materials that have been used in the Eastern settlement to better understand their exploitation and availability to the Norse in Greenland. My focus is mainly directed at the stones, which is one of the most common and preserved find types, and these materials were both local and imported. By looking at their types and origins, we can hopefully estimate what sort of access the Norse had to foreign imports and whether the Greenlandic landscape could provide enough adequate material substitutions to minimize reliance on import or even take its place if it fell through from time to time. From the data collected, we are hoping to add further details to models of Norse material exploitation and exchange networks and add a new dimension to the debate about the nature and quality of life in Norse Greenland. As I said earlier, the project is centered around 2 main artifact assemblages. One is from a midden of a small farmstead in a place called Tatsip Ataa Killeq in Vatnahverfi, which is here, if you can see that. The midden was excavated between 2009 and 2011 under the supervision of Konrad Smirowski, a PhD student at the University of New York. In the excavations, over 5,000 finds were unearthed that have been dated roughly to the 11th to the 14th centuries. And of those, there were just under 1,500 stone finds. The other assemblage is from a secondary midden formation excavated in 2012 and 2013 in a meadow close to the farmstead at Igaliku or Garðar in Einarsfjörður, which is here. The excavation was directed by Dr. Orri Vestninsson, and over 9,000 finds were unearthed, estimated to be from the 12th to 15th century context. Of those, there were just over 500 stone finds registered in total. which is a much smaller number than recorded at Tatsip Ataa. However, find size was much larger. At Igaliku, the average stone find weight was around 80 grams per find, while at Tatsip Ataa, stone finds weighed only about 9 grams on average, which clearly demonstrates how very fragmented the Tatsip Ataa stone assemblage is compared to the one from Igaliku. The Igaliku assemblage can be roughly split into two periods from the finds and carbon dating to the 12th to 13th and 14th to 15th centuries. In both collections, wood and stone finds were the most common. In this bar graph, we can see the main rock types represented in the finds that were found in the two middens. Only finds that could be phased are considered here. Finds from test trenches could often not be clearly connected to the main excavation sites and were therefore set aside, but they would not have changed the overall trends much in any way. Both assemblages are surprisingly similar, as there are only 4 main rock types or groups: soapstone, sandstones, chert minerals, and schists, along with a few miscellaneous finds and fragments of, for example, coarse volcanic tuff, pumice, coal or pitchstone, and feldspar crystals. Undiagnostic finds were mostly natural rock fragments or fragments that were too small or degraded for analysis. About 25% of the stone finds, soapstone finds, were useless beyond being simply ID'd as such. And of that, about 7% of that came from the Igaliku assemblage and 17% from the Tatsip Ataa. In both assemblages, soapstone is by far the most common rock type by count and weight, with Eriksfjord sandstones a close second, but it is interesting to note that at Tatsip Ataa, the quartz mineral assemblage is notably much richer than at Igaliku, or over 200 finds against only 9. Why this should be is unclear, but it seems likely to be somehow connected to different formation processes between the two sites. You can see here in the gray, the third minerals from Tatsip and from Igaliku. The find assemblages have been roughly phased with the aid of radiocarbon dating of, for example, seeds, nuts, bones, and textiles, alongside relative group or context locations within the trench sequences. The phases are still a work in progress, but the general picture is considered unlikely to change much, and there is no scope for a narrower range than 1 to 200 years. There are indications of frost action disturbances in the top at Tatsip Ataa contexts, which may have messed with some of the radiocarbon dates, and as many of the contexts there are thought to be discarded floor depositions, they may have confused the dating even further and perhaps masked changes in material exploitation through time. At Igaliku, the top contexts have also been mixed to a degree by modern disturbances. The soapstone has been split into diagnostic and undiagnostic categories. About 30% or 160 fragments of soapstone finds from Igaliku and about 72% or over 600 fragments from Tatsip Ataa are undiagnostic in terms of further type classifications, as the finds are too fragmented or degraded. In the Tatsip Ataa assemblage, there seem to be very little changes in rock type ratios through time, while at Igaliku, however, Eriksfjord sandstone and chert minerals seem to be more concentrated in the lower contexts, although reasons are still unclear. The greatest difference between the two assemblages is that while over 200 finds of quartz minerals were found at Tatsip Ataa, only 9 fragments were found at Igaliku. The mineral finds were roughly grouped into rock crystals, manuports, that is fragments with clear, rounded, wind or water-worn surfaces or indications of being amygdales, undiagnostic fragments and debitage flakes with sharp edges, and finally strikolites and their possible chippings. None of the flakes showed any clear indications that they were formed or used as any kind of tool, such as scrapers, arrowheads or knives. Most of the microcrystalline quartz fragments are more likely to be chert formations originated in igneous, metamorphic or siliceous sedimentary rocks rather than flints formed within chalk beds and therefore possibly imported. More likely, they are more likely to be local rather than imported. Here we see a few examples of chert fragments that were found at Igaliku and Tatsip, and we have possible either microcrystalline chert or possible flint fragments, but there were few. We have quartz rock crystals, a few whole ones, and we have flakes with sharp edges, and then we have fragments that look like they have been formed in some sort of voids and are most likely amygdales, and then we have more fragments of amygdales that are clearly banded, and then we have undiagnostic fragments that show no clear indication of what they may have been used for. As you can see, I just very quickly split the finds from Tatsip Ataa into quartz crystals, which are all translucent gray, like the one above, and then monoparts and amygdales, which have been somehow transported to site, but don't show any indications of work other than being broken. And they are from white to light gray and translucent to green. And then we have debitage flakes with sharp edges and undiagnostic fragments, and they are of many types of different colors. And then we have possible strikolites that show percussion marks and possible chippings from them. And they're all over the range in color in the collection. Oh, sorry. There we go. The Igaliku finds consisted of 2 rock crystal fragments, 2 dark green chert fragments, where one is a possible strikolite, red and brown opal and jasper fragments, and 3 gray microcrystalline chert flakes. In this bar graph, the 200 Tatsip Ataa quartz minerals have been grouped by morphology and color. Rock crystals for decoration, possibly, or gathered for perhaps some sort of superstition, but most of the rock crystals are rather badly formed. Fragments possibly originated in quartz veins within metamorphic rock, possibly. Monoparts and amygdales are often fragmented, as I said. The debitage flakes and fragments have sharp to worn edges and are possibly minerals that have been chipped and fragmented for a reason, but to make tools or strikolites, but don't show any indication of work other than that, and no specific forms. But most of them are not likely to come from any substantial outcrops, single outcrops or formations. The Eriksfjord sandstone, the majority, if not all of the sandstone in Eriksfjord, is in varied shapes of dark pinkish or wine red, often with flecks of bleached white, alongside a few gray sandstone finds that often also have hints of red in the fine matrix. The grain size ranges from microgranular, where individual grains in the stone cannot be seen with the naked eye, and the stone is almost jasper-like, to moderately coarse, where grains are clearly visible and up to 1 to 2 millimeters in diameter. Most commonly, however, the sandstone is fine and well cemented with a grain size below 0.5 millimeters. At Igaliku, there were 72 sandstone finds. Only 15% are undiagnostic fragments without clear purpose. 61% are thin flakes that may have been formed through chipping, and 13% are fragments that are often thin and long and have one or more polished or striated surfaces. At Igaliku, there were also 1 or 2 possible hand tools. In the much larger assemblage from Tatsip Ataa, there are 305 sandstone finds. 60% is undiagnostic fragments. 22% of the finds have 1 or more polished or striated surfaces that could have been part of a whetstone or polishers, while only about 7% or 19 finds are large enough to potentially be identified as whetstones or polishing stones. Finally, only 8% are possible flakes or chippings, along with 3 pieces of possible strikalites and 7 manoports. This bar graph shows the interconnection of the morphology, color, and texture of the most common find types at Tatsip Ataa Killeq. Majority of the find types are fairly fine to microgranular, while only a small part of the assemblage down here is more coarser sandstone. So the whole assemblage is really rather fine in grain size. As I previously stated, Soapstone was the largest part of both collections. It is difficult to categorize and analyze as it is often fairly soft and textures and colors are easily smudged and contaminated on the surface through time. The soapstone was roughly split into 15 groups, mainly based on grain size, color, and texture, where it could be seen in clean fractures and magnetism, level of magnetism. In terms of type, 30% of steatite at Igaliku and 73% of the Tatsip Ataa steatite were undiagnostic, either due to small size or material degradation. As you can see, there are very many different textures of the soapstone, and as I say, it's categorized through texture, grain size, the colors, types of crystals that we see, and they could be roughly categorized into these 4 groups. But as you see, most of the soapstone finds that could be analyzed fall into this one single group, which is basically general steatite that has a coarse to fine texture. It's mottled white to gray. It's non-magnetic or magnetic. The problem is that even though you can sort of roughly categorize them into different boxes, one single outcrop of soapstone can have different textures. Part can be non-magnetic and another part can be magnetic. So very often these textures can't be said to come positively from different areas or different outcrops of soapstone. Both collections could be roughly grouped into the same categories. But these categories, however, cannot be used to indicate distinct or similar sources, as soapstone can show large morphological variations within one quarry. Igaliku had a few more distinct types not found at Tatsip Ataa, although not in any great numbers, which are these 12, 13, and 14 groups here. Only 5 to 10% of the grouped collection was fairly fine and compact steatite, while the rest was fairly coarse-grained and looser, for example, containing a lot of hard and fibrous crystals of amphiboles and plates of biotite, and was therefore likely not very good steatite without enough talc to bind the material together. Only one baking plate fragment of schistose steatite was found at Igaliku, that is likely Norwegian. Otherwise, the feeling is that this is most likely Greenlandic soapstone rather than Norwegian soapstone. There are no indications of any clear changes in the use of the different steatite types through time, but only on both sides, a large part of the preserved material is in the topmost disturbed layers from the 14th and 15th centuries. There are fairly few schist fragments in both collections. Only 11 pieces of schist whetstones were found at Tatsip Ataa, and only 2 fragments of schist at Igaliku. The schist in the whitish blue or purple gray whetstones in the center found at Tatsip are likely to originate in Eidsborg in Norway, these 2 here. The light gray to the left is in a more gray area and could possibly resemble the raw local schist found at Igaliku. This is the schist found at Igaliku, and this is a light gray whetstone that possibly could be of similar material, but it's not in any way certain. The light gray to the left is a more gray area and could possibly resemble the raw schist found at Igaliku, but this is unconfirmed. Samples were taken from all the schist types at Tatsip for chemical analysis. The distribution between phases could suggest early presence of Eidsborg schist before local schist took over, but this is pure speculation as the assemblage is simply too small to guess. So we have 2 more very likely Greenland schist here to the right. One found at Igaliku and the other found at Tatsip Ataa, and these types are much more only in the top phases, while the Norwegian ones and the light gray are here down in the lower earlier phases. Finally, there are a few stragglers, and here are just a few notable examples to mention. There were very few finds from both sites that are made from rock materials other than soapstone, sandstone, or quartz minerals, or only less than 2% on either site. There were 2 fragments of coal, one from Tatsip and the other from Igaliku, although one was found in a test trench, so it technically shouldn't count. Or one pumice fragment with clear indication to have been used for polishing. It is unlikely to be Icelandic, but Icelandic pumice has been found in Greenland. And another hand polisher made of finely banded claystone with unclear origin, which is on the top here. There's also a part of a quernstone from Igaliku made from coarse-grained silicic tuff, likely post-13th century. It is possible that there is also another quernstone fragment at Igaliku made from soapstone, but the more I think about it, that is a very dubious. It's a very dubious theory. It's a very rough fragment. So, and soapstone wouldn't be a really good fragment or material for quernstones. Whether these were querns for grinding cereals for meal or bruising malt for brewing is unclear. Neither material is a very good grinding medium, but could possibly have sufficed for bruising malt in a pinch. Eriksort sandstone would potentially be too brittle for quernstone production. And the fragments of large feldspar crystals, both at Tatsip and Igaliku, could possibly have been jewelry, rock fragments for jewelry, like the rock crystals. This is a big feldspar crystal. This is likely to be coal. We think we saw some plant material in there, but it could also be pitchstone. The majority of the Greenlandic geology is much older and vastly more complex than in Iceland, but the two midden assemblages at Tatsip Ataa and Igaliku don't reflect that complexity. At first glance, the usage and range of quartz minerals are fairly similar to Icelandic collections, but the overall range of rock types in the two assemblages is very simple compared to Icelandic sites, where various rock types of the local geology are better represented. Import types, however, are fairly similar as they are in Iceland, mainly schist, steatite, and possibly flint and coal. Little of the various types of local indigenous rock that are found in the Eastern settlement, like basalts, granites, syenites, and gabbros, seem to have been used for tools like querns, weights, or hammers, or at least they are not found in these two assemblages. Where transported soapstone, local, and sandstone seem to largely take their place. And where transported soapstone and local sandstone seem to largely take their place. Here you can see the general geology of the area around the two sites. Consideration of Greenland geology and potential sources are still a work in progress, but with regard to quartz minerals, it is very likely that the majority of them don't come from any one homogeneous source that can be located with any certainty. It is most likely that they are redeposited from water as secondary minerals at varied temperatures in a myriad of locations and can form in any of the varied and widespread rock formations in the Eastern settlement, whether they be granites, syenites, basalts, gabbros, or sandstone. The red formations are giant dikes made from gabbros or syenites. The dark pinks are syenites, that's a type of igneous rock. The gray areas, they are basalt formations from the Gardar period. The purple are granites, and the dark blue are diorites and gabbros. While the yellow, the bright yellow areas are sandstone formations, the Eriksfjord sandstone formations. Thick formations of red sandstone are found on both sides of Eriksfjord, as you can see, along with lenses of coarser conglomerates, and they are here shown in bright yellow. As you can see, the largest sandstone formations are on the Narsaq Peninsula here, intermingled with basaltic lavas hundreds of meters thick. They are also southeast of Narsaq here, on both sides of the fjord, as well as around Kassiarsuk and Igaliku, here and around Igaliku. There are also similar sandstone sediment formations closer to the rim of the Greenland Glacier, far up here. But these are much more unlikely sources of sandstone that has been used on these sites. Poulsen's published work on the Eriksfjord sandstones is not very detailed and cannot be used to suggest any specific source locations for sandstone extractions in the area without further research on site, although they were no doubt many. In 2004, Hans Christian Olsen reported many places along the coast from Ammassalik up to Melville Bay. Here, Ammassalik and up to Melville Bay. Of those, there are at least 9 areas from Cap Farvel in the south to Siglufjörður in the eastern settlement, and 3 in the middle settlement over here. Dr. Christian Madsen and his team at the National Museum in Nuuk are actively looking for potential sites and have already taken samples from Sakarmiut, which is down here. Potential areas where there are ultramafic rock formations, like for example carbonatite, pyroxenite, hornbladite, and amphibolite, for example on Tuktutok, which is here, and around Narsaq, here at the edges, and in Brattahlíð around here. Historical sources suggest there was an extensive soapstone source in a place called Deer Island, which would most likely be Tuktutok, but no quarries have been located there as yet. In the middle settlement, soapstone is most likely to be found here. For example, in connection with serpentinite formations in and north and northeast of the main settlement, which are here where the purple and the green formations are. There are also mica schist formations south of the middle settlement and in Greenland, around here and here in Greenland. But we don't really know anything more about the what type of schist or how big they are. But Carsten Sacher, the geologist in Denmark, has suggested that the schist may be local, Greenlandic, rather than imported. There is little doubt that schist could be found in other areas in the eastern settlement, like the metamorphosed sedimentary zones at the southern tip of Greenland, down here. But I have not found any information with regard to such outcrops or exploitations. A lot of work is left to do to be able to map the potential and extent of human exploitation of geological sources in Greenland, because while the geological research is really detailed and good, they are more focused towards modern usages of rocks and mapping of rocks that are useful today, rather than which rocks would have been useful to the Norse. Most especially, there is need to map known soapstone sources in more detail, as for example in these areas where Hans has located potential sites. In more detail, to identify what types of geological formations are being used, to see if it is possible to extrapolate and to perhaps predict or find more soapstone sources in those areas. So this is as I say, a work in progress. This year, for the rest of this year, the project will continue this year. Samples for chemical analyses to determine potential provenance have already been chosen, and 17 samples were taken from the Igaliku collection in February. And the Tatsip Ataa collection is much more fragmented, and not many fragments qualify to be good material to sample. But 23 fragments have been chosen for further analysis later this year. Geologist Gurli B. Meyer at the Norwegian Geological Survey will be directing the preparation of samples, running the analysis and interpreting the results. The samples will be used in X-ray fluorescence analyses to determine the main chemical elements, and then reused for detection of trace elements and rare earth elements through mass spectrometry. In addition, a few samples were also taken for thin sections to aid in the microscopic analysis of soapstone textures and rock composition. Hopefully, the bulk of these analyses will take place in the spring and early summer, followed by data processing and write-up in the late summer and through early winter. But we have to see how much more COVID restrictions mess up our schedule before we can say anything more about that.